Let's take a look at example 4 from section 2.4. Again, we're asked to find the range, mean, variance, and standard deviation of the following sample data set. We'll begin by finding the range. That's just the difference between the max and the min. The maximum value of this data set is 18. The minimum is 5. So the range is 18 minus 5, which is 13. In order to find the rest of the values, we can use our calculator. I would first want to go ahead and enter this data set in. I have everything sorted in list L2. So I'm going to go ahead and hit stat, calculate, one variable statistics. And I recommend you all using L1, but I'm just going to put it in L2 to save time. I want my frequency list to be blank because I'm just using one set of numbers. Go ahead and hit enter. And we would see that the mean, notice that this is sample data. So the calculator is actually giving us the correct notation. A sample mean x bar would be 12.78 rounded to 2 decimal places. The other thing the calculator will give us is it will give us the standard deviation. Very important, you have to know which one to pick. Because we have sample data, we need the sample standard deviation, which is S. S has the value 4.29. So 4.29 would be our value for S. The calculator will not give us the variance, but we can calculate the variance by just taking the standard deviation and squaring it. If I square 4.29, that would give us 18.40. Again, be a little bit careful when you're going and working in WebAssign, in MyStatLab. If I square this rounded value, it might be enough to throw off my variance by a little bit, so much so that MyStatLab might actually mark it wrong. It's a good idea that whenever you're using your standard deviation to find variance, take it out a few more digits. I'd recommend doing about 5 or 6 decimal places when you do your squaring. So I have 4.29469. So I would do 4.29. Let me just see that with that one more time once again. 29469. And then I can go ahead and square it, and that squared key is the x squared button. It's right here. Go ahead and hit enter, and notice that it does throw it off by a little bit. Our answer is a little bit more accurate than what we had in the notes here because we took it out a few more spots. So to 2 decimal places, it should round to 18.44. Again, if this was a test or an exam, I would give you full credit either way because I know that you would know what you're doing in terms of finding the variance there. Sample variance is s squared, so s squared equals 18.40. But just be aware that MyStatLab might be a little bit picky. Take the standard deviation at least 5 or 6 places before you square it to find your variance. The last thing that we're going to look at together in this section is what's called the empirical rule. This is for symmetric or bell-shaped distributions. It's also sometimes memorized as the 68, 95, 99.7% rule. What this tells us is that if you go within 1 standard deviation of the mean, so here's x bar, if you go 1 standard deviation to the left and 1 standard deviation to the right, that would encompass 68% of the data values. 2 standard deviations to the left and to the right would give us 95% of the data values. And then you're going to have about 99.7%, or for almost all intents and purposes, almost all of the data set will lie within 3 standard deviations of the mean. So very important, this is called the empirical rule. It only applies to those symmetric bell-shaped distributions. Again, know those 3 sequence of values. 68 within 1 standard deviation, 95% within 2 standard deviations, and then 99.7% within 3 standard deviations. And typically on a symmetric distribution, this is how we label our axes. The height of the bell is always corresponding to the mean, and then you add the standard deviation usually 3 times to go to the right for this x scale, and you also subtract the standard deviation 3 times to go to the left for the scale. in addition to the 68, 95, and 99.7%, which are kind of the classical values, we can also use those to find some of the percentages in other regions. For example, because the symmetric distribution is equally split down the middle, if we know it's 68% within one standard deviation, if you take half of it, that means that 34%, which is half of 68, would lie between the mean and one standard deviation. We could also figure out, for instance, how much would be between 1 and 2 standard deviations by doing the following. We know that it's 95% from here to here. If you subtract or take away the 68%, 95 minus 68, that would give us 27%, which would be both here and here combined. If you take half of that 27%, that would tell us that there's 13.5% in each of these little regions. In example 5, they tell us that the mean value of homes on a street is 125,000 with a standard deviation of 5,000, and that the data set has a bell-shaped distribution. The moment you hear that, it's a good idea to kind of go ahead and start to do the graph. This is a sample mean, so it's x bar. The sample standard deviation is s, that's 5,000. So the height of our bar, the highest point should be at 125,000, and then we could add s to go to the right. 125 plus 5 would be 130,000. Add another 5,000, that's 135,000. And we should really go one more for completion, but 3 standard deviations would be right here. That would be 140,000. We can also subtract the standard deviation to go to the left. 125 minus 5,000 would give us 120,000. Subtract it again, 115,000. And then if you go 3 standard deviations to the left, the one more value we would put would be 110,000. If we wanted to estimate the percentage of homes in this neighborhood that would be priced between 120 and 130,000, notice that graphically that's 1 to the left and 1 to the right. Our empirical rule would tell us that that's going to be 68% of the home prices. If they ask what percentage of homes would be priced between 115 and 135, notice that that's 2 to the left and 2 to the right. That is going to be your 95%. And then as a follow-up, if they said, suppose that the sample was of size 35, how many of those homes would we expect to be priced between 120 and 130,000? Well, 120,000 to 130,000, that was 1 to the left, 1 to the right. We know that that's 68%. Therefore, we would expect 68% of our sample, or 68% of 35, that's 0.68 times 35, would give us about 23.8, or we would expect 24 homes from that sample to be priced between 120 and 130,000. Let's take a look at 2 more of these. Suppose we have the mean value of land and building acre for a sample of farms is $24,000 with a standard deviation of 450. And again, we're asked to assume that the data set has a bell-shaped distribution. So I would always recommend begin by just plotting it. So our bell shapes, draw a nice bell-shaped curve. X bar corresponds to the highest part, that's the 24,000. And now this time we're going to scale our axis by the standard deviation S, which is 450. So you add 450 to go to the right 3 times, subtract 450 3 times to go to the left. The first question says, between what 2 values would 68% of the data set lie? Remember, 68%, that's 1 to the left and 1 to the right. That's going to be between $1,950 and $2,850. Between what 2 values would 95% of the data lie? Well, that's going to be 2 to the left and 2 to the right. If we already have our graph, we can just look it up. That's going to be between $15,000 and $3,300. Let's look at one more. They say that the mean cost of internet per month for a sample of households was $49 with a standard deviation of $2.50. Let's assume that these prices are normally distributed, so they have a bell-shaped curve, so it's going to look like this. Estimate the percent of internet cost between $44 and $54. Well, if we try to look at where this would be at, if we take our 49, that's the mean, the standard deviation is 250. If we subtract the standard deviation twice, we get down to 44. If we add it twice, that brings us up to 54. So this is 2 to the left, 2 to the right. From the empirical rule, we would know that that's going to be our 95% interval. So we would estimate that 95% of those values would fall between $44 and $54. Suppose we had a sample of size 100. About how many would have monthly cost between $46.50 and $51.50? If we come back up here, 49 minus 250, that's 46.50, and 49 plus 250 would be 51.50. So this range they're giving us is one standard deviation to the left and one standard deviation to the right. That would be our 68% interval. So we would expect 68% of our sample, in other words, 68%, 0.68 times 100, or 68 values would be between the two given prices. So this is the empirical rule. It's 68, 95, 99.7.